And let's start with polynomial functions first, okay? So let's call this polynomial function. Okay, this is the general form of polynomial function. General form, okay? That means if any functions um, takes the type of what we've shown here, then it is considered the polynomial functions. Um, these, the blue ones, we call this the coefficients. Okay, we call this coefficients. Okay, that means it's not a variable. Variables are this x's. Remember, this is a function of x. All right. So these are the one thing that varies. Okay, so probably you have oh yeah, another thing is the x here um, is a real is a real number. Okay, so real number, this means real numbers. Okay, so we are not dealing with any imaginary numbers right now, although later you'll find some instances or situations where hey, suddenly an imaginary number pops up when we talk about roots. Okay, so polynomial function can take the form of anything. Let's say, for example, I don't know, let's say function of gx. So let me ask you this: is this a polynomial function? Is this it?
Yes.
Yes.
Yes,
Okay.
sir.
All right. What about this? If I have something like this, x to the power of 5 plus 2. Is this a polynomial function?
Yes.
Yes. You see,
Yes.
those coefficients, it doesn't need to be, those coefficients can be a real number. So even in this case, the coefficient for x to the power of 4 and x to the power of 3, x to the power of 2 and 1, for example, they are all 0. All right. And then you will have something like this. So this is also called a polynomial functions. So usually what you've learned before, I'm sure that um, you have learned how to find roots of a polynomial functions. Okay, and if you are familiar, even if you're not familiar with this, I think I'm sure you have seen this one here. Um, say for example, yeah, if um, you want to find the roots, find the roots of, let's say, a quadratic function, ax squared plus bx plus c, then what do you do? So the roots, all right, the roots can be represented as
Explain as
minus
minus 4AC.
4a times c. Okay, all right, the highest degree of quadratic function is 2, so you're gonna get two roots. What I'm saying here is if your polynomial function highest degree is 2, then you're gonna get the same amount of roots. So if this is quadratic, the highest degree is 2, then you are going to have two roots. Okay, and you find the roots for quadratic function, for quadratic here, by using this formula. But for cubic or quintic or higher degree polynomial functions, you cannot use this formula. So this is only for quadratic functions. What is a root? Okay, so I'll say here. So let me give a definition here. A root of a polynomial function, all right, is a value x. So let me just write x asterisk here, just to separate it from other. So value such that if you such that fx, that root will become 0. Okay? So if you can find, uh, if you replace replace the x's in here with the root of the polynomial function, then the whole function will go to 0. All right, example. Okay, what do I mean by this one? So let's say we have an example of a function, let's say x squared plus x. Okay. I think from looking at here, do you know what x will give fx equal to 0? Can you tell me? Just one. It has two roots, but what is the one root that will make fx go to 0? Say that again. Huh? Negative 1. Let's try negative 1. So if f is negative 1, then we got minus 1 here squared plus minus 1. This becomes 1. Sorry, 1 minus 1 becomes 0. Yes. So in this case, one of the roots is x equals to minus 1. That's great. Who was it just now? Siapa yang cakap tu? Ah, Sheen. Thanks. That's correct. If you are smart, can you? If I'm asking everyone, can you find another one? 0. Yes, because let's try. Is it true? 0 is the one of the roots of the function. Let's say 0 squared plus 0. This becomes 0. Yes. Another root is x equal to 0. All right. So the roots of this quadratic function here are minus 1 and 0. Find roots of, I'm going to give a cubic for, you know what? To the power of 4. X to the power of 4 raised to the fourth, and then maybe x to 1 and 2 plus 9. I'm just making up numbers here. All right, so this one, what degree is the polynomial? 4. That's the highest degree. Okay, so let's try and find that. Let's find the roots of that function. So Wolfram Alpha will give you those two roots. Okay, how many roots do we have here?
It should be 4.
Yeah, it is 4.
I think
Yeah, you can see here plus minus. So plus this value here, if plus this thing here is 1 root, minus this thing here is 1 root, plus this thing here is 1 root, and minus that thing here is 1 root. Okay, let's try something else. Let's try 5. I'm just making up things here. I don't know what I'm gonna get. Okay. Ah, there you go. So you got 5. So you got 5 roots here because the highest degree of the polynomial is 5. Why polynomial functions are important? Why is it so powerful? Okay, so this smart guy here, Weierstrass, he said that every continuous function defined on a closed interval, that means closed interval from 0 to 1, or I don't know, minus 10 to plus 10, all right, can be uniformly approximated as closely as desired by a polynomial function. What he's trying to say that even if you have like a, okay, let's say x and this is fx, okay, and let's say you have any continuous function, doesn't matter how it looks like, all right, from a to b. So this is a and this is b. All right, this random curve here, I'm not saying random in the mathematical sense, but this curve here can be approximated by a polynomial. You can actually find a polynomial that, I would say, approximate or traces this curve as close as, as close as possible. Approximation, right? So anything. Say, for example, you have something like this. I don't know, maybe a weird function like this. Yes, you know what? Those blue curve, that blue curve can also be approximated by polynomials. So polynomial functions are powerful. The next thing that we always use is what we call trigonometric functions. So basically, anything that has sine function, cosine, tangent, or cotangent, what else? Secant, cosecant. All right. So we call this trigonometric function. If you have a function that looks like this, some coefficients times sine, times, let's do cosine. Cosine x plus b, some coefficient times sine x. Okay. All right. This is an example of a trigonometric function. Okay. Some coefficient times cosine x plus some coefficient times sine x. You can always represent it in a times sine of x plus a, like that. Okay. Now, how do you find big A in terms of small a and b, and how do you find the alpha in terms of small a and b? So the formula is this. So you got to write it down here, yeah? So in this case, a over b. All right, so you got this, you can find this. All right. Now, this here, I will put a box because it's important to know. Okay. Okay. It's a formula, yeah? If you want to change this into this, then you can use this formula right here. Yesterday, what we've learned is something like this. A times sine, in bracket b, x plus alpha plus c. All right? Now, we are going to look into this A here, what's B here, what's alpha here, and what's C here. Okay? So, let's say this is what we call the amplitude of the um, trigonometric function, and B here dictates the period. Okay, where period in this case is equivalent to 2 pi over whatever you call B there. Okay, 2 pi over B. So this is A, and alpha there is what we call phase shift. I will put phase shift left because any positive number here will move it to the left. And then this is what we call vertical shift. Vertical shift. Okay. All right. I think I got a picture. It's better for you to understand. Okay. I think this one. All right. Can see? All right. Can you see this? Let me copy and paste this on the chat box. Ta-da. See? In the chat box. Chat. Okay. Upload. Okay. Keep this in your notes. All right. So this is the same as what I've written here. It's the same thing. All right. So A dictates the amplitude. That means, okay, the amplitude of the wave here. All right. So the bigger the number A, the bigger the amplitude. Right. And then B here dictates the period. Period means you can say the distance between two maximum peaks here. All right. So the larger this value, the closer they are. That means shorter the period. Okay. And C is the phase shift left. That means if this is positive number, it's going to move to the left by. Uh, so if this is positive, it's going to move to left. If the number here is negative, it's going to move to the right. So it's going to shift the whole thing, the whole wave into the left if it's positive. And then the final number here, D, which in this case I think what I've got is actually C, and then that one is alpha. C here is the vertical shift. That means it pushes things up or down. Okay, something like that. Okay. Oh yeah, you know what? I that one used the different letters here. They use C and here is D, so don't be confused. There's a shift, phase shift, and that one is vertical shift. It's the same thing here. I think I got it from another textbook. This one here. So in if you are in exam, for example, in your test, I will give you this. Okay, for example, I'll give you a function. Okay, and then I would say if I increase this value right here, b, what's going to happen to the function? All right. So let's try something. Let's try. So I have to do this b times x plus alpha, okay, plus something c. Okay. So I want to plot something that has an amplitude of 10 and period of 2 pi. So period of 2 pi, let's see here, if a period 2 pi, so b needs to be 1, okay? So I got 1. X alpha, I don't want any shift yet. I just want to put that 0, and I don't want any vertical shift, okay? So this is just a simple sine function, okay? All right, sine function with 1 with b equals to 1, which means that if you look at this again, b period will be 2 pi over 1, which means it's 2 pi. So is it 2 pi? Is it correct? Let's start here. 1 pi, 2 pi, correcto. Okay, here, this is 1.5 pi. Okay, yeah, 2 pi. Now, let's see what's going to happen if I put a shift here. Let's say put a number 5 here. I'll just put random number here. See what's going to happen to the plot. Ah, kacau. Ooh. Oh, it's too much. You cannot see the ni. Let me just put 1. I'm going to put +1 shift here. You can see it's shifting a bit to the left. Can you see? Yeah, it's shifting. Let's say if I shift it by pi. How do I write pi here? Can I write it like this? Oh, yes. See, everything is shifted to the left by pi. All right. If I remember, this is the original one, yeah? This is the original one without any shift. Okay, imagine. Okay, it starts with that and downward. Okay, if I shift to the right by half pi, what's going to happen? Oh, it's going to shift to there. Oh, you know what? Let me try this. Let me try this. Let's say this has no shift and this one has a shift. What's going to happen? Pi 2. Can I do this? Hopefully you can recognize that as 2. Oops, made a mistake here. You go crazy. Sorry. Let's see. Well, okay. Yeah. All right. So the red one, the blue one is the original one. Okay, this one here without the shift. And if I shift it plus pi 2, so it's shift backwards. You can see that. It's just shifting the whole thing backward like that. And if I add a vertical shift, for example, I add a vertical shift of 2, let's see what happens. Let's see what happens to the The maroon one. Ah, see, it's shifted up. The red one shifted up. Okay, I just want to shift it a bit here by whatever amount. I would say let's 1. See what happened. Ah, it's shifted up. It's kind of crazy and shifted a bit to the left because I add pi over 2 plus 1. Okay, I want to make the amplitude smaller. I say 2. Let's see what happens. Ah, okay. Ah, I see. This is the original function just now, 10 times sine x. There's basically just a sine function. And this is the weird trigonometric function that I've just concocted. Okay? So the point here is you have to remember what each of these coefficients do to your function. So this one increases the amplitude. This one, it changes your period, the distance between the two maximum peaks. All right. And then this will, positive number will phase shift it to the left, shift the whole thing, the whole graph, sorry, the whole plot to the left a bit. And C determines this vertical shift. All right. I think let's do some activities, yeah, just to check your understanding. This one clear? Is everyone clear? Yep.
So the graph only can shift to the left.
Yeah, no, you can shift it to the right. Examples, yeah? Good question. Who was asking just now?
Munir.
Okay, Munir. All right, if you want to make it shift to the left, you can just put a minus sign. All right. Okay, I'm going to start again. So I'm going to do the same thing without any vertical shift. Okay. So I'm shifting it to the right. See? I put 2 here, minus 2. So what it's doing, it's shifting this point here to here. Ta-da! You see it? It's shifting to the right. But if I put plus here, it's shifting it to the left. See? Shifting this to the left. There's 2 there. That's 2.
Oh, so if we want to make it a vertical shift
Mhm.
to the upper, so we must put it positive. Then
Yeah,
we
if
want to go
vertical
down
shift,
negative.
correcto. So if you want to shift it up for a bit, for example, shift it up plus 5. And you can see that maroon thing is shifted up 5. That, 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 up here. Okay, if you want to shift it down, just put minus sign. Now it's shifted down. There you go. So basically, all right, you can play around with this. If you got trigonometric functions here, if you want to shift it left, right, up or down, you can always just use this. Change the amplitude, change the period. You can always use those 4 things here. A, B, and here we use alpha before, use alpha, and here we use C. It's the same thing. Okay? All right. Good question. Okay, let's do some examples, shall we? Oh, oops, my camera. Let's do some examples, okay? Let's do this one lah. This one. All right, take a look at that. Let's do it in this here. Okay, so example or exercise. Okay, let's say fx is 3 times sine x plus 4 times cosine x. Okay. And I would say express this trigonometric function in the form of this big A sine x plus alpha. I hope it came out right. Okay, there you go. Let me put some, to not confuse you more, let me put some parentheses here so that it will be clearer for you. There you go. All right, look at the chat box here. Okay, so you got f of x equal to 3 times sine of x plus 4 times cosine of x. Express this trigonometric function in the form of a times sine of x plus alpha. And use this formula just now here. Okay, I hope you have written this in your notebook, and then tell me what you got for this one. Okay. All right. All right. Another 10 seconds. Namira and Ami Imran, finish your answer. For Afisa wants to try to. Okay, finish your answer. 0.97. Oh, hey, we got two answers here. One answer is, okay. One answer is 5 times sine of x plus 0.927. And the other answer that's being thrown around is 5 times sine x plus 53.13. All right, so okay, so you're also correct. So this is in radian, and if you change it to degree, you're right. You're right. Okay. Let me show you how to put a sign using this. Here, I'm going to show you one time, and I need you to do it after this. Okay. See my code. Can you see my code? No?
Yes.
Okay. So my code 53.13, and then you put this sign, you put slash CRC. Okay. And then close bracket. Ta-da! Okay. Let me put a bracket down there. Oops. Okay. And this is my code. This is my LaTeX code. Tag code. Okay. I put it like that. Okay. So it's clearer if you don't put degree there. I don't know if it's. I will just assume it's radian. For exponential function, let me write down some formula here for exponential function. Okay. Sorry, I forgot to tell you this one here. Exponential function. These are just some rules of exponents. I'll write this down in your notes. So let's say you have, a to the power of m times a to the power of n. So this will be equal to a m plus n. Okay, I think you probably know this already from your high school math. Okay, if you have something like this is equivalent to a m minus n. Okay, and then this is number 1, number 2, number 3. This is oh yeah, this is provided that a is not 0, yeah, because if a is 0, then this will go crazy. And the third one is if you have a to the power of m and the whole thing to the power of n, so this will be equal to a m times n. All right. Okay, take a picture of this or write it down in your notes. Okay. And then logarithmic function. There are some rules also. All right, some rules. If you have, let's use different color here. Let's use brown. No. Yeah. Whatever that color is. So let's say you have natural log of m times n. So this can be expanded to natural log of m plus natural log of n. Okay. No. Okay, m n. Okay, and then if you have a natural log of something like m to over n, so this just means that it's minus that. And finally, if you have a natural log of m, which is raised to the power of p, okay, then this will become p times natural log of m. Okay, so those are the I would say some rules of exponent and rules of logarithms. Okay, I'm going to put it here. Okay, I'm going to put it here. So you can copy and paste this in your digital notebook, or you can write it down in your physical notebook, whatever. Okay. All right.